Smog is a combination of smoke and fog. And fog is a pretty normal occurrence, all different parts of the country. It can be more severe based on topographical conditions, the ups and downs, changes in elevation. Weather patterns play a huge role in the formation of fog. But the basic conditions to create a foggy morning are what we call a thermal inversion. Thermal means heat and inversion means flipped. Cold air trapped underneath warm air. Remember that warm air is less dense. Warm air likes to rise. So if you start the day with cold air on the bottom, it's not going to move. It's just going to sit there. And it's not until the sun comes out and warms up that bottom layer that we get the air flowing again. Now, the problem with that, if we have a cold, foggy morning, we get up and we drive to work. And all of those cars release more pollution into the air. And what we end up with in the afternoon is a very hazy day as things heat up. And that's an example of smog. The fog from the morning mixes with the smoke and pollution from the drive, and it becomes a gas called ozone, which is really what hazy smog is. So once again, a thermal inversion is when cold air is trapped underneath warm air. Generally occurs in the morning, produces fog. Now, in places like Indianapolis, we're pretty lucky because if we do have a foggy, smoggy morning, because our terrain is mostly flat and our weather moves from one direction, it typically blows the pollution off to the east. And we already talked about acid rain, how that goes out east. Here you see a place, though, that has mountains. You see that the mountains can actually serve as a barrier and trap that smog longer throughout the day. So some cities do suffer worse based on their topography. I already mentioned to get rid of this when wind can't blow it off to the east, you have to simply wait for the sun to heat everything up, heat up the bottom of the troposphere. And the process that circulates the air is called convection. Warm air rises, cool air sinks, things go back to normal. There are actually two main types of smog, and you will need to know this difference if you're taking the AP exam. The first one correlates with the industrial revolutions that we've seen. As their population expanded, coal was the dominant fuel source. Burning all of that coal quickly polluted their air. And you can see they were losing thousands of people a year to smog-related deaths. Gives me a good chance to review from earlier this semester. Remember that there are different qualities of coal. Here you see the different versions, anthracite being the cleanest. And remember the difference between them is really the sulfur content. Bituminous is going to have a lot more dirty sulfur than anthracite. You're also going to have things like lead, mercury that are in those coals as well, nitrous oxides. But sulfur is the big important one. Also, remember I gave you the example of evolution that was caused by humans. And this was the peppered moth. The white peppered moth used to blend in with the bark. And as the Industrial Revolution took over, the dark pepper moth was able to blend in with the soot and became the favored species or version of the species. Okay, so London was first, but we saw the United States embrace coal in the 1920s through the 1950s. By the 1970s, we realized, oh, we're ruining our air. And that's when the Clean Air Act came out. And so we went through the same thing. We had smoggy cities in New York, all up and down the Great Lakes and the East Coast. And then we fixed it. We started to put limits on the pollution. We installed scrubbers in the 1990s. Well, guess who's going through the exact same thing right now? It's Asia. We've got huge population, high energy demand, and coal is the cheapest, easiest way to meet that. So China, India, these countries are experiencing terrible smog problems. We know what the answer is. It's just a matter of, will we commit to fixing it? China's made some progress and then kind of slid back. They realized that their alternative energy is not able to keep up with the energy demand, so they've started burning more coal again. Now, the other type of smog is the ozone one, photochemical smog. Photo means light. We're talking literally about photons from the sun. Chemical is a reaction that takes place. So smog that comes from the sun and things that come out of our tailpipes. Instead of gray smog, this gives us more of a brownish color, and it's the nitrogen dioxide, reddish brownish color. Remember VOCs, volatile organic compounds? That's going to be things like methane, propane, butane, or we burn all those fuels. We call it natural gas. Chemicals like formaldehyde, benzene, they're carcinogens. Those get into the air. They evaporate at room temperature. So all that stuff goes into the air. The sun zaps it and breaks the molecules apart. And what that does is it frees up oxygen atoms. And those oxygen atoms then rebond with O2. So the final product is ozone, which is O3. Just adding one extra atom on. And you understand that O2 is essential for us to be alive. You add an extra oxygen to it, and it's poisonous in the troposphere. That's Los Angeles on the left. We sometimes call photochemical smog LA smog. That picture on the right is from last spring when we went into lockdown. And as people stopped commuting into the city, just like in India, the air instantly cleaned up. And we've got oxygen atoms way up high in the stratosphere. And those get zapped by ultraviolet, which breaks them apart into single oxygen atoms. Those then bond to other diatomic oxygen, and we get stratospheric ozone. That's tomorrow's lesson. That's the good stuff. Stratospheric ozone protects us. Now, nitrogen oxides build in the morning. That's our car exhaust. Even with catalytic converters, there's nitrogen oxide that gets into the air. Factories are also a culprit. So we see that nitrogen oxide can combine with oxygen to make nitrogen dioxide. That's the one that makes acid rain when it mixes with water. But if we don't mix it with water, if we zap it with UV, it breaks it apart and releases that free oxygen atom, which then goes to make ozone. Ozone in the stratosphere comes from oxygen. Ozone at the ground comes from nitrogen oxides. And remember, the sun comes in and heats things up, and that's why ozone actually peaks in the afternoon. That's why we get hazy afternoons when the air quality is bad. Really, this is a summary of what I just showed you. We've got different kinds of smog. When it is sulfur related from our fuels and our mostly coal power plants, particulate matter, moisture, that makes gray smog. On the other side, we've got our factories that release VOCs, nitrous oxides, gasoline, that produces ozone throughout the day and is our photochemical or brown smog. So what can we do about it? Well, there's actually some easy solutions that everybody could help improve our air quality. In states that are progressive like California, they have strict vehicle emission standards. And just like we go in and get our license plates renewed each year, so they get certified to confirm that their car is not releasing too much levels of ozone creating pollutants. There's a controversy back in 2015 as laws were being made to make cars more fuel efficient and less emitting. Volkswagen lied. They produced almost 500,000 cars around the world that technically did not meet the emissions. In fact, they weren't even close. They were emitting 40 times the amount of nitrogen allowed. They got called out on it. Somebody finally caught on that, oh my gosh, these cars are actually not meeting the standard at all. And so Volkswagen had to recall them all. And they were able to lease a bunch of the land, 21,000 Volkswagen cars parked there. A very expensive recall. All right, what can you do? Because you don't design cars yet. Some of you might someday. We came up with a catchy phrase, no zone action day. And it's KNO, as in knowledge about ozone. And so our meteorologists on all the TV channels started using it. They would come on in the morning and say, we expect this afternoon to be a no zone action day where air quality is going to be low, pollution is going to be high. So we're asking people to not fuel up their vehicles during the day. Maybe bump your air conditioner up a degree or two so that it's not running as hard. Don't mow your grass. Remember, gasoline engines that don't have catalytic converters. Try to carpool. Don't sit in drive-throughs. Now, electric cars are going to solve all of those problems, right? This first one's kind of weird. Why can't we fill up our gas tanks? Well, you know, when you pump gas, you don't get all the gas. Some of it evaporates on the spot and goes into the air. That's why they don't want you to smoke at a gas pump. You could ignite the vapors that come out. Well, we have invented what is called a vapor recovery nozzle, basically a fancy gas pump, which holds some of those vapors in the tube instead of out in the air. So what do you really need to know? You really need to know that photochemical smog is cars, ozone and nitrogen, and industrial smog is coal, sulfur, other things found in coal. All right, Zoom folks, that's all we got today. Thanks for hanging out.